Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Muhammad Haikam bin Saini, and I would like to present to you our manufacturing team presentation about pil Lajak Kuruih J. Okay, now I would like to introduce to you our manufacturing team. First is me, Muhammad Haikam bin Saini, as the production manager. Second, Muhammad Shahaizat bin Shah Arifin, the distribution manager. Third, Muhammad Ikhwan bin Yusof, the Quality Control Manager. And finally, Muhammad Jailani bin Maine, Operation Planning Manager.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan bin Yusof. So I will present my team about I will explain about part A. So for part A, I will cover about the describe and summarize the sample data that I have gotten from the assignment, and we will present about our Lajak Kuruih J. So let's go it. Okay, here I have already summarized the data that I found from the question from the assignment for the production of Lajak Kuruih tablet for December 2020. So here I have the separated for evening, morning, and shift. So here is the sum of weight for evening, morning, shift, sum of relativity for each shift, and sum of tensile strength for each shift. For sum of weight for evening, we have around 21,000 milligram. For the morning, we have 26,000, and night we have 22,000 milligram. And the total total is 70,000 milligram. How I get this equal is this value is I use the SL function of equal sum, and I highlight all of the weight of for evening, and we automatically find the value of it. So this total for relativity, I also use the same method, equal sum, and also tensile strength. And here I have already make it as a graphical for information, so it'll be easier to find. So here we will find out that the number of sum of weight is higher at morning shift, and also the sum of tensile strength is the highest because you have the highest sum of weight, where it's around 532.5 MPa, and for the total sum of weight is 26,525 milligram. Next, we will go to our standard deviation. How do I find the value of standard deviation? I use the SL function by using equal standard deviation, and I highlight all of the value alternative for each shift, and the value will come out here. So what we got here, standard deviation for weight is 13.9894 for evening, morning we have 12.9475, and night we have 12.5850. For the relativity, we have 1.8 for evening, 2.09 for morning, 2.25 for night. For the tensile strength, we have 0.1919 for evening, and for morning was 0.21, and lastly for night we have 0.2084. Lastly, I found out the average for weight, relativity, and tensile strength for each shift. How do I find about this value is by using the SL function equal average, and I highlight all about the weight from all the value of weight for evening, morning, and night. So what I get here is the average of weight for evening shift with 350.9585 milligram. For morning we have 353.6741 milligram, and night you have 350.5756 milligram. And the average between this shift is 351.7361 milligram. As for relativity, we have found out that it's average of 88% for evening, 88.0613% for morning, 88.2438% for night. And the average tensile strength for each shift is 7.1131 MPa for evening, 7.1 for morning, and lastly 7.1141 for night. Yeah, I make it into a bar chart to be easily understand, where average of weight mg for each shift, where we found out that the highest average is for morning around 353.6741 milligram, and the lowest is at night 350.5756 milligram. And that is all for part A. Thank you for listening, and now we will go to part B. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikam bin Saini, and in this meeting, I would like to comment to you about our pil Lajak Kuruih J is follow the normal distribution that required by the FDA, which is the sample mean weight of the required is 350 milligram and the standard deviation is 14 milligram. So we get in this our sample, the mean weight is 351.7361 and the standard deviation is 13.1739 milligram. We have 200 sample overall for the PLJs, and then first of all I would like to show you the sampling distribution. In this we use the normal distribution, we convert it into the standardization value, so we get it in this table, and then we minus with one minus with the value that we get from table, and we get 0.9686. And then after that we use the confidence interval for the mean, which is CI for 95%. The critical value we get 0.05. In this formula we use the population variance. The population variance is unknown, so the number of case is more than 30. So we use the case 2. We replace the sigma with the s, and then we get in the table 1.96, and then we use to Z test. We get the range of 351.9406 and 348.0594. So our sample mean of PLJ is in this range, so it is passed. For the confidence interval of variance, we also use the CI for 95% and the critical value we get 0.05. So we use the chi-square test and we get it the range. And then after that, we get the range of 162.5438 and 241.0243. We square root this value and then we get the standard deviation of this PLJ 12.7493 and 15.5250. This is the range, and our sample standard deviation of weight is in the range, so it is passed. Then we go to the next. We use for the test of hypothesis mean. So the null hypothesis here is follow the required FDA. So the mean is 350, and then the selected hypothesis is we choose there is difference with the required FDA. We use the critical value 0.05, and then the answer date we get 1.96 from the table, and then we use to put it in the Z test, we get it 1.8637. So this value that we get is lower than 1.96, so it is not in the shaded region, so it failed to reject the hash null. And then after that we use test hypothesis for variance. Also the hash null follow the required FDA standard deviation, critical value 0.05, and then we use the chi-square test, we get it the range 239.96 and 161.826. So the chi-square test formulas we get 176.208. So it is over the range that we get here from the table, so it is rejected. It is need to reject hash null. And then finally I show you the goodness of fit for the PLJ. We use also 95% the significance level, and then hash null follow the normal distribution from the required FDA, which is mean 350 and standard deviation is 40. So in this we use to distribute into the three range. Each range has 10 interval, so we get it the frequency, and then for this we use the standardization formula from this range, so we get it in the range, but we only use to choose 6 range, because in this 7 range, the last range, we get EI is lower than 5, so we merge with the upper value, and then we use to calculate 6 only. And then after all we get it from the table the range, and then we calculate the range, and then to get the EI we must multiply with the total volume sample, and then this is the original frequency, and then we use to put in this chi-square test formula for the goodness of fit, which is OI minus EI to the square power of 2, and then we divide it with the EI. So We get each of it and then we total up and then we get the value of chi-square test 2.0175. So we get it to the then we get from the table chi-square with the critical value of 0.05 and the degree of freedom is 5 because there is 6 range here we choose, so we must minus with 1, so we get it here 11.0.705. So our chi-square value is lower than this 11.0705, so it is failed to reject the hash null. And then decision rule, which is we do not reject the hash null at the 0.05 significance level. Thus, we follow the hypothesis of the weight of tablet J follows the normal distribution that have been required by the FTA. So that's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Shahizad bin Syarifin. My ID is B18KA0032. I'm from section 20 and I'm from group J. Okay, my job is must answer from question C, which is comment on whether there is any significant difference between tablets which from the different shifts. The method by using one-way ANOVA in Microsoft Excel. The objective is to indicate if there was any difference occurring between the population means from which sample come from. ANOVA single method procedure. First, hypothesis statement. H0 is equal to mu1 equal mu2 equal mu3. H1 equal mu I not equal to mu j for at least one where I not equal j and ij equal 1, 2, 3. D is Excel output summary from one-way ANOVA. From my cursor, we can see the summary table which has group divide to 3, morning, evening, and night. From this question, this data, we can conclude that number of factor get 3 and number of sample get 200. From my cursor, you can see this is ANOVA table. We get the F value is 1.102641. Next is decision rule. Decision rule reject H0 if F calculate is more than F 0.052197, which is equal to 3.041753. The conclusion, sin f calculated equals 1.160261 is smaller than 3.041753. Do not reject H0. We can conclude that alpha equals 0.05 level of significance, that there is no significance difference in tablet weights from the different shifts. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day doctor. Okay, Ms. Muhammad Jayani, and I will continue the part 2 for the regression analysis of field Lajak Kuruih group. Okay. Okay, what is regression analysis? Regression analysis is a relationship between one or more response variables and one or more predictor variables. Okay, there are two parts, which is response variables and predictor variables. Response variables are also known as dependent variables. So in this case, the response variables is tensile strength. Meanwhile, the predictor variables are also known as independent variables. So for this case, the predictor variables is relative density. Okay, as you can see from this chart, I have plotted the relative density line fit plot. Okay, from this slide, you can see that the blue dotted line indicates the tensile strength, and the yellow line indicates predicted tensile strength. So from the linear equation, which is y equal to mx plus c, where y equal to tensile strength, m equal to gradient, x equal to relative density in percentage, and c equal to intercept value. Then from the predicted tensile strength, given the relative density values of 68%, 74.3%, and 80.1%, we can find the tensile strength of the tablets using previous equation. So when the relative density value is 68%, therefore y equal to 0.0854 times 68 minus by 0.413, which equals to 5.3942 megapascal. After that, when relative density value is 74.3%, therefore y equal to 0.0854 times by 74.3 and minus by 0.413, which we can get the value is equal to 5.9322 megapascal. And lastly, when the relative density value is 80.1%, therefore y equal to 0.085 times by 80.1 and minus by 0.413, which equals to 6.4275 megapascal. Next, okay, for the conclusion, in conclusion, we can say that the linear regression model is valid and acceptable to predict the test result of the tensile strength of the tablets based on its relative density with up to 95% accuracy. Okay, doctor, that's all for me. Thank you.